In this video, we're going to learn two new similarity theorems. So one of them is side angle side similarity, and then the other is side 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 similarity. So for the first one, side angle side similarity, the abbreviation for this would be to put side or SAS with the similarity symbol, making sure that you include the similarity symbol because we do have SAS for congruence, and side angle side for similarity is much different. What's different about it is the fact that the sides have to be proportional. So what it says is if one angle of a triangle is congruent to another angle, so the angles are going to be congruent, but then the lengths of the sides are proportional. So the lengths that make that angle the included angle, so the lengths of the sides are proportional. The two sides that touch that angle or make that angle the included angle have to be proportional. Then the triangles are similar. So that's going to be important to keep in mind that the sides or the S's stand for proportional sides, not congruent sides. And then the other theorem is side 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 similarity, which again is different than SSS for congruence because side 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 similarity, so you want to include that similarity symbol, means that all three pairs of corresponding sides are proportional. So the corresponding sides are proportional, and then that would make the triangle similar. So there's really three things to keep straight here when you're talking about similarity. Angles are going to be congruent, sides are proportional, and then the triangles are similar. So that's important to keep all that notation and vocab separate. So angles are congruent, sides are proportional, triangles are similar. So if we use these new theorems, SAS similarity and SSS similarity, we can use those to justify if two triangles are similar. So in this first picture, without knowing anything about the angles, but if I just compare the corresponding sides and they're in the same ratio, meaning they're proportional, then I can say that the triangles are similar by side 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 similarity. So what I'm going to do is compare the corresponding sides. So 4 to 2, that reduces down to 2. And then if I compare 2 to 1, that reduces down to 2. And then if I compare 6 to 3, that reduces down to 2. So what this means is the triangle, so I'm going to say triangle ABC is similar to triangle DEF by side 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 similarity since all corresponding sides are proportional. And I know that the corresponding sides are proportional because they're in the same ratio. So that's what that means. So moving on to example 2, we have some different side lengths that we need to measure first, or write first. So XZ, so this entire thing is 12. VZ, so this part here is 4. ZW is 2, and ZY is 6. So what we want to do is we want to see if triangle ZVW, so the small triangle, I want to compare that and see if it's similar to the big triangle, ZXY. So what that means is I'm going to look at, well, I have two sets of sides given to me, and I have the included angles must be congruent, which in this case, the included angle between these sides that I have is going to be congruent in both triangles because of reflexive property. So I know angle Z is congruent to angle Z by reflexive property. So that's considered the included angle between those sides because it's touching both of those sides. And then if I compare the small triangle to the big triangle, when I go to set up my ratios, well, that would be 4 to 12. So that's going to reduce down to 1/3. And then 2 to 6, that's going to reduce down to 1/3. So what that means is I have the included angle as congruent, and then those sides that make up that angle are proportional. So this information tells me by side angle side similarity that these two triangles have to be similar. So ZVW is similar to ZXY by side angle side similarity, because the sides are proportional and the included angles are congruent. So something like that, something worded that way, where you talk about the two sets of sides that make up that included angle are proportional, and then the angles are congruent, the included angle. So the last one here, let's go ahead and label. So we have 12, CD is 6, AC is 8, CE is 6, DC is 4, and DE is 2. So start matching up our pieces here. So we have 12 is going to correspond with the 6, so 12 over 6 is going to reduce down to 2. 8 corresponds to 6. So if you reduce this, divide the top and bottom by 2, you end up with 4/3. So right away I can see that these sides are not in the same ratio, even though the last side, 4:2, that is in the same ratio as the first sets of sides I compared, but I can see right here that not all three sides are in the same ratio, which means that these triangles are not similar. So triangle ABC is not similar to triangle CDE because not all corresponding sides are proportional or are in the same ratio. So therefore, the triangles are not similar. So there you have it. So these are they're kind of like informal proofs in a way, because you're explaining, you're just deciding if they're similar and then writing an explanation, but it's not a formal proof. So it does get us started though with looking at these similarity theorems. So go ahead and check your understanding problems, get your key ideas down, and we will talk about those tomorrow in class.